Hi there. In this video, we'll take a look at problem 23 from the semester exam review packet. Here we're given the formula y equals 4x minus 3, and we're asked to find the minimum value of the product x times y. Well, let's get our hands dirty, try to develop a feel for what this problem is about. So what I'm going to do is just generate a couple of ordered pairs that go along with this equation right here. All right, let's see. I'm just making this up off the top of my head. If x is 5, we get 4 times 5 is 20, take away 3, so y would be 17. If x is 6, we get 4 sixes, that's 24, take away 3, you get 21. Okay? Now, what I want to know is, okay, in relation to this problem, what is the product of x and y? Okay, let me just pick up a calculator for this part. The product of 5 and 17 is 85, whereas the product of 6 and 21 is 126. So between the two values that I generated, this would be the smaller product. Okay, we are interested in the minimum. But the question is, can I make the product smaller? Let me just randomly see what happens when I decrease the input down to 4. 4 to 4 is 16, take away 3 is 13, and now I'm getting 4 times 13, which would be 52. So right there, I was able to get smaller than 85, but again, I'd like to know if I can get smaller still. And ultimately, we want the absolute minimum for this function. All right, so this is where calculus comes into play. Let me stop guessing and checking and start doing calculus. Okay, so the minimum, let's see. Maybe it'd be helpful to take a derivative here and see what we can learn. All right, so we have the function x times y. Okay, let's just call that function capital F. And knowing that y is equal to 4x minus 3, we can substitute that particular expression for y. Okay, so I'm just going to write 4x minus 3 in place of y. Now we can distribute, giving 4x squared minus 3x. And so now we have a function of the variable x. And we'd like to find the minimum of that function. All right, so we want the minimum of this, which is the same as these other two expressions, so we're just minimizing this quadratic function. What's the min? Okay, so we'll find the derivative, which is 8x minus 3, and we would like to know where that's equal to 0. And apparently that's 0 when x is 3/8. So 3/8 is some interesting number on the graph of this function, but let's do a little better than that. Here's 3/8. Okay, what does f look like? Well, it's a parabola. It's going to be facing up, so it's going to go like that. And apparently it just exactly touches the axis there. So it's going to be a positive value, and then 0, and then positive again. Okay, let me stop and think about what's going on here. Oh, sorry. That was the graph of f itself. Okay, I meant to be discussing f prime here. So let me just take a step back. Oops. Now, f prime is just a line. Okay, so that is going to be negative, 0, and positive. All right, if you think about the line 8x, it has positive slope, so it's just going to go like that. And so we're going to get negative values up to here when the derivative is 0, and then positive values. Okay, so what's the inference about the function itself? Well, since the derivative is changing from negative to positive, okay, we can visualize the graph decreasing and then increasing. In other words, that value is truly a min. Okay, and that's what we were after, so I believe we've solved the problem. The minimum value occurs when x is 3/8. So let me make some room for what's happening next here. when x is 3/8, we get a minimum for this formula right here. Okay, but now we need the corresponding y value, so we'll go back to the original equation. Y equals 4x minus 3. And we'll write 3/8 for x. So what is that? 3/2 minus 3. This is like 3/2 minus 6/2. So you get negative 3/2. Okay, so we learned that the minimum occurs when x is 3/8, which means y is negative 3/2. And now we just want the minimum product. So let me just form a product with these guys right here. See what we get. X times y. X times y. And that gives negative 9/16. Okay, so when I was doing guess and check, I was able to get, gosh, I forgot now, but some positive number. I was able to get it smaller. But the smallest value that this function has is actually a negative quantity, and it happens to be negative 9/16. And that's the minimum. Hope this video was helpful. See you next time.